A green roof is a roof of a building that is partially or completely covered with plants and soil. These roofs, also known as living roofs or vegetated roofs, are seen as environmentally friendly and as a step toward sustainability. There are both advantages and disadvantages of green roofs in comparison to traditional roof systems. Green roofs provide additional insulation for heat and sound. A living roof maintains vegetation and a habitat for plants, birds, and insects. The plants used help purify the air, and green roofs help regulate the stormwater runoff system through reduction and delay. There are also drawbacks to having a green roof. A green roof system costs more to install and is more difficult to maintain. It also uses water, while a traditional roof system does not. A living roof uses more materials and can shorten the lifespan of a building. Climate is also a concern. If the building is in a cold climate, snow loads will have to be addressed. In areas that receive large amounts of rain, additional water will need to be factored in. Green roofs start at around $8 a square foot and vary depending on level of intensity. There are two main categories of green roofs: extensive roof systems and intensive roof systems, with degrees in the middle being called semi-extensive or semi-intensive. Extensive roof systems usually consist of a basic ground cover with low-lying plants grown in 2 to 4 inches of soil. Intensive roof systems have taller plants in 12 to 24 inches of soil, a complex drainage system, and structural allowances for any additional dead loading. This is the Acros Fukuoka, which stands for Asian Crossroads Over the Sea. It's a mixed-use commercial building completed in 1995 in Fukuoka, Japan, which includes an exhibition hall, museum, theater, conference facilities, government and private offices, retail space, as well as underground parking. The city was in need of a new government office building, and the only available site was a large 2-block park that also happened to be the last remaining green space in the city center. Argentinian architects Emilio Ambaz and Associates got the job because their design maintained half of the 5-acre park while still giving the city the building. The Acros has 14 floors above ground and 4 more below ground. It's made of steel-framed, reinforced concrete. The soil and vegetation insulate the building, lowering heating and cooling costs 20% and overall energy consumption. The terraces also reduce the building's heat island effect and capture rainwater runoff. The terraces are open to the public. People visit the gardens for exercise or for views of the harbor and city. The Acros started off with 76 varieties of plants, totaling 37,000. Now, because of insects and birds, those numbers have almost doubled. There are waterfalls that start at the top and run down the building to mask the ambient noise of the city. On the south facade, there is a central glass atrium that provides the interior with natural light, but most of the daylighting is provided by the curtain walls on the other 3 sides. The staircases to climb the terraces double as fire escapes, which left more leasable space inside the building. The front of the building faces north in the city's busy financial street. The stepped garden is not accessible from the inside of the building except in emergencies. The city of Fukuoka considers the Acros a success because it balances the need for both commercial and public space. It created new open space equal to the amount that was lost to the development. The Mashantucket Pequot Museum and Research Center, designed by Polshek Partnership Architects, was built in Mashantucket, Connecticut in 1997. The building celebrates the history and survival of the Pequot Nation. The architects wanted a design that would celebrate the native culture that respects the environment. Most of the structure is underground. By being underground, the artifacts are protected from moisture. The circular space is for gathering. Research is done in the long building, and visitors can go to the top of the tower to view the lands of the reservation. The museum's roof is a 2-tiered terrace landscaped with native plants. American Hydrotech installed the 75,000 square foot roof system, which cost $2.5 million. The Mashantucket Pequot Museum and Research Center's green roof reduces the building's impact on the adjacent wetlands, while visually blurring the line between the built environment and landscape. Singapore is home to the School of Art, Design, and Media at Nanyang Technological University. This building, designed by CPG Consultants, was completed in 2006. It's made up of 3 main blocks that enclose a plaza. It has a green roof, which weaves in and out of the ground, appearing as if it's growing out of the soil. Before the project was started, the site was a wooded area, and the school wanted to preserve as much of it as possible. The building was designed to blend in with its landscape instead of dominating it. Almost all of the building is glass and grass. This made the construction of the nearly 33,000 square foot roof a challenge. Usually a turfed roof needs soil for growing, which puts a heavy load on the building structure and foundations. The architects for this project came up with a unique system that is made of a thin layer of lightweight volcanic stone and sand, but still allows the grass to grow. The composite section has an absorption mat that can soak up water during showers and release it during dry spells, along with a single-ply waterproofing member. Fine manila grass was used for this project. The roof took over 4 months to install. There were 2 main challenges: to keep the planting material lightweight and to plant grass on a roof that slopes as much as 45 degrees. The roof was designed to be eco-friendly so that it can deal with the hot and sunny Singapore weather using a limited amount of water. This grass roof provides a communal space for students and is also very visually appealing. The new California Academy of Sciences in the Golden Gate Park of San Francisco, California, was a $429 million project that broke ground in 2005. The project replaced a series of the Academy's buildings that were damaged in a 1989 earthquake. The new Academy was completed 3 years later in September of 2008. Renzo Piano, the architect of the project, looked at the green roof as a metaphor. He stated, "I saw it as a topography. The idea was to cut a piece of the park, push it up 35 feet to the height of the old buildings, and then put whatever was needed underneath." Following this theory, the green roof's rolling hills were determined by the program underneath, rising where more space was needed, such as the planetarium. In all, there are 7 hills, which echo the 7 hills in San Francisco. This groundbreaking project was also certified LEED Platinum. Some of the strategies that earned this rating were recycling 90% of the demolition waste from the old buildings, incorporating insulation made from recycled blue jeans, employing heat recovery systems to capture and use heat generated by the HVAC equipment, using radiant heating in the floors, ensuring that 90% of the space had access to daylighting, and naturally ventilating almost the entire building. The green roof consists of 6 inches of soil, which provides thermal insulation, keeping interior temperatures about 10 degrees cooler than a standard roof. The roof also reduces stormwater runoff by 98% and reduces low-frequency noise by 40 decibels. The 197,000 square foot green roof also creates a 2.5-acre habitat for 1.7 million native California plants and all kinds of insects and birds. An interesting feature of the project is the circular skylights that dot the hills of the roof. They're fitted with heat sensors and open to further cool the building when a certain temperature is reached. As well as being a green roof, the roof also incorporates 60,000 photovoltaic cells that generate between 5 and 10% of the Academy's energy needs. Overall, the building consumes 30 to 35% less energy than required by California's already strict building codes. The Academy of Sciences is one of the forefront buildings in the movement of environmentally friendly design. Green roof systems do have their pros and cons. While they may not be the right choice for everyone in every building, they can be beneficial if used in the proper capacity. If you're thinking about a green roof in your next project, make sure you speak to a licensed architect who can help you decide if one is right for you.